Welcome to part 2 of the 5.4 notes. All right, guys, so what I think you should do in this case is go ahead and pause the video and give example 3 a try on your own. See what you come up with. It is asking you to use a trapezoidal rule of Riemann sums with the subintervals implied by the table to approximate the value of the integral from 3 to 14 of f of x dx. So pause video, see what you come up with. All right, so when you're given a table of values like this, and it says to use the subintervals implied by the table, the first thing that we want to check is, are the widths the same? Okay, do they have the same width? So from here, my first interval is going from 3 to 4.5. That's a width of 1.5. My next interval is going from 4.5 to 7. That's a width of 2.5. So clearly they are not the same. My next interval is going to go from 7 to 10, which is a width of 3. And then we go from 10 to 11.2, that's a width of 1.2. And finally from 11.2 to 14, that is a width of 2.8. So you have varying widths. It's important to identify that there are varying widths, because what that means is we're going to need to find the trapezoidal Riemann sum by finding the area of each trapezoid separately. Okay? Now, you want to remember the formula for the area of a trapezoid is 1/2 the height times the sum of the bases. So base 1 plus base 2. So I'll go ahead and color code these. So for the first trapezoid, when we go to find the area, our first trapezoid is going to be what I have kind of the interval in blue. So it's going to be 1/2 the height, which is the width of the interval, 1.5, times the sum of the bases, which are 2 plus 8. Plus, the next one I have in green, so we're going to have 1/2 the height, which is the width, so 2.5, times the bases, which is 8 plus 11. My next trapezoid is the one that has a width of 3. So we're going to have 1/2 3, and then the bases are 11 plus 16. Next, I have the trapezoid with a width of 1.2. So we have 1/2 of 1.2, and then the bases are 16 and 12. And finally, we have the trapezoid that has a width of 2.8. So the height, whoops. Sorry, I was trying to color code all this. So it's 1/2, the height is 2.8, and then the bases are 12 and 7. So from there, what we would need to do is plug that into our calculator and evaluate what the actual interval, or what the actual area is. So I'm going to go ahead and do this kind of quickly. 2 plus 8 is 10. 10 times 1.5 is 15. And then obviously 15 divided by 2 is 7.5. So this is going to be 7.5. Plus, all right, 8 plus 11, that's 19. 19 times 2.5 is 47.5 divided by 2. That's going to give us 23.75. All right, 11 plus 16, that's 27, times 3 divided by 2. That's going to give us 40.5. And then 16 plus 12 is 28, times 1.2 divided by 2. That's 16.8. And let's see, so there's 1, 2, 3, 4. We got one more. 12 plus 7, that's 19, times 2.8. And then if we divide that by 2, we get 26.6. And when we add all those together, we've got 7.5 plus 23.75 plus 40.5 plus 16.8 plus 26.6. And you get an area of approximately 115.15 units squared, because it doesn't tell us what units we're using. All right, and again, guys, the integral, when we evaluate that definite integral, it's telling us the area under the curve. So the area between the curve and the x-axis. And that's what we get here. All right, let's take a look at example 4. So again, I would pause the video right now, give it a shot on your own and see what you come up with, and then check to see how we do it. All right, so this time it's going to ask us to use a midpoint rule to approximate the area between y equals 11 minus x squared and the x-axis. We're doing it on the interval from 0 to 8, and we're using 4 subintervals. So, basically what we're doing is we're approximating the integral from 0 to 8 of 11 minus x squared dx. All right, we're approximating that using a Riemann sum. So the first thing we need to do is figure out what is our width. All right, and the width is going to be 8 minus 0, okay, that's the total length of the interval, divided by the number of subintervals, 4, which gives us 2. All right, so they have an equal width. Now, the next thing we're going to need to do is figure out what values to use for the height of our rectangles. So, if we're starting at 0, okay, if we're starting our interval at 0, and there's a width of 2, then that means our first interval goes from 0 to 2. Well, we are using a midpoint rule, so the midpoint from 0 to 2 is 1. So we need to evaluate the function f of 1. My next interval is going to be from 2 to 4. The midpoint is 3. And then we're going to go from 4 to 6. The midpoint is 5. And from 6 to 8, the midpoint is 7. So we're going to evaluate the function at those values. So we've got 11 minus 1 squared. We have 11 minus 3 squared, 11 minus 5 squared, and 11 minus 7 squared. So that's going to be important. 11 minus 1 squared, that's simply 10. 11 minus 3 squared, that's 2. 11 minus 5 squared, that's a negative 14. And 11 minus 7 squared, that is negative 38. Now what you want to remember is that negative area means that the function is below the x-axis at that point. So that area is going to be below the x-axis. All right. And, we could sketch a little diagram of what's actually going on right here. If you have y equals 11 minus x squared, that's going to be a parabola that's opening down that's shifted up 11. So this point's up here at 11. It's shifted down. And, what we're kind of looking at is some of the area, 8's going to be somewhere over here. You've got some of the area that's above and some of the area that's below. So as you go through, like if this is, let's just kind of see this here real quick. If this is 2, 4 is going to be over here, 6, so 2, 4, 6. As you're using your midpoint, we're using the height of the function right here for that interval. We're using the height of the function here for that interval. And those are above. And then you're using the height of the function down here for that. Well, this rectangle is now below, so it's negative, and then so forth. All right, so that's to kind of give you a visual of what's happening as you, find that area. So as we apply, the midpoint rule, the formula is the area is going to equal the width because it doesn't vary. And then basically it's going to be f of 1 plus f of 2 plus f of 3 plus f of 4. Plug in our numbers. The width of our intervals is 2. F of 1 is 10. F of 2 is 2. F of 3 is negative 14. And f of 4 is negative 38. Guess I probably should have just used brackets. All right, and inside those parentheses, we basically have 10 plus 2 is 12. 12 minus 14 is negative 2. Negative 2 minus 38 is negative 40, which gives us an area of approximately negative 80. I don't know why I did 20. Sorry. 2 times negative 40 is negative 80 units squared. So that's how you could use a midpoint rule to approximate the area between the curve and the x-axis for that function. All right, guys, that takes care of part 2 of the notes. Please make sure you check out part 3.